Hi friends, I am Gautam and I am physics faculty in SAIVEDA Junior College. Now the topic what I am teaching you is logic gates. Logic gates. Here this logic gates is belongs to the chapter name semiconductors. Semiconductors. The advantage of learning this topic is even you are in first year or in second year or you are doing long term, anyone can easily understand if you pay attention, because even you don't have knowledge of semiconductors also you can handle this topic called logic gates. That is the advantage here. And second thing is, here if you are thorough with this topic, definitely in any national wide competitive exam you can handle one bit, and that is happily not only in a NEET, APMT, JMS, whatever it may be the competitive exam, you will be facing one bit from here, and it is a very advantage to score and it will be in your pocket. So let us enter into this topic, logic gates. Fine. Here I am starting this logic gates with different gates. That is the first one I selected as OR gate. OR gate. What is this OR gate? This OR gate perform one logical operation here. What is that logical operation? We will observe. Before entering into that, remember that is symbol of OR gate. Symbols are very important here. You have to be clear with the symbols. You must not get confused for different gates. This OR gate symbol will be like this, and the two inputs I have taken is A and B, and output is A plus B. Output is A plus B. That means for this gate, A, B are inputs, output is A plus B, and that is the symbol for logic gate OR gate. Let us observe the truth table for OR gate. Here truth table means we will be having here two inputs and again one output. The input already we noticed is A, other one is B, and the output what we had A plus B. Now let us take first inputs as 0, 0, and 0 plus 0 we get again as 0, and again we'll take 0, 1, 0 plus 1 is what we had is 1, 1, 0, 1 plus 0 is 1. Now the last two inputs are 1, 1. So what we call 1 plus 1, we must not say it is 2. Why? The reason is 1 plus 1 here, not numerical 1 and 1. 1 indicates high value and 0 indicates low value. According to our binary system, 1 plus 1 is again 1. In binary system, these are not numerical 1, numerical 0, these are not numbers, and here it is 1 indicates a high value, 0 indicates a low value. These are binary system, zeros and ones. That is the reason 1 plus 1 we have to take it as 1. It is a high value plus high value is again what we got, high value, that is a 1. That is how we have to construct the truth table for OR gate. Please observe carefully. Here if both the inputs are low, that is both are 0, 0, we are getting the value again, output is 0. If 0 and 1 is there, we observe 1. 1 and 0 is there, 1. Or both ones are also 1. That means what we can understand here, the logic for this OR gate is, if any one of the input is 1, the output is 1. Or both the inputs are 1 also 1, but if both the inputs are 0, the output is 0. That means definitely to have a output 1, one of the input also must be 1, or both inputs are 1. That is a condition. In that type of condition can be exhibited by this OR gate. That means the logical operation for OR gate is either or both the inputs are high, then only we can get the output as high, that output is 1 and 1 is treated as a high value. If both the inputs are 0, that is both the inputs are low, then the output again it is low, that is nothing but 0. Okay, I think that you are clear with the truth table. Let us again come back to the symbol for OR gate. The symbol for OR gate and truth table, the two things you have to remember till the end of the topic here. This is the very important which you have to observe. Please observe carefully. The symbol is OR gate, we can draw like that, and the truth table for that one. So if you can remember these two things till the end of the topic, you can easily handle any problem. Let us now enter into our next gate, that is AND gate. Here again for AND gate, let us observe the symbol which is simply two inputs with one output. That inputs are A, B, and output is A dot B. We observe here the symbol for AND gate. Pay attention of the symbol. You have to remember each and every symbols and truth tables. This is a symbol. Already we observed the OR gate symbol and truth table. Now we observe the AND gate symbol. Let us enter into the truth table for the OR gate. So OR gate truth table means again the same way we have here the two inputs and one output A, B, A dot B. As we have taken the same inputs in the OR gate 0, 0, 0, 1, 1, 0 and 1, 1. Same way what we observed in OR gate, I have taken the input same thing in AND gate also. You can observe. The first one is 0, 0. What will be the output for 0, 0 means 0 dot 0. We can observe it as 0. And 0 and 1 means 0 into 1. We can find it as 0. 1 into 0 we can find it as 0. And 1 into 1 as 1. This is the truth table for what gate? It is the AND gate. And again for formality, I am drawing you the symbol also. Pay attention on the symbols. Very important. Both the things. This is a symbol and what we are observing is truth table. So symbol of AND gate and the truth table of AND gate. You have to remember these two things till end. Here you observe 0, 0 we are taking inputs, what we got? 0. 0 into 1 what we got? 0. 1 into 0, 0. 1 into 1, 1. From these observations what we can conclude? The conclusion is very important here. So our conclusion is only when the two inputs are high, then only output is high. That means both the inputs must and should be 1 and 1 to get output 1. If any one of the output is low, then what we found is again the low outputs. So in the OR gate, what we observed, any one is high, the output is high. Both are high, also output is high. But in this AND gate, if both are high, then only we have high. That is the difference between OR gate and AND gate. And that is the conclusion for these two gates. Let us enter into our next gate called NOT gate. The NOT gate means just it performs inversion. What is that inversion means? Suppose first we will observe the symbol. Symbol for NOT gate is simply we can keep like this, one circle in front, and this becomes NOT gate symbol. And what NOT gate performs? Inversion operation we told. That means we are giving A as input means it gives as A bar. What is this A bar? We can also call it as A complement. So A will become as A complement. That means if you have given the input as 0, it will become as 1. If you have given the input as 1, it will become as 0. So it is just changing whatever the input you are giving, it changes the input. That means if you give the low input, it will give the high output. If you give the high input, it will give the low output. That type of performance is done by NOT gate. Let us observe the truth table also. Here truth table means, again here we don't have two inputs here, just only one input, that is A, and output is what we noticed is A complement. That means if we have taken as 0, it is becoming as what? 1. If you have taken as 1, it is becoming as 0. That means whatever the input you are taking, it reverses that performed by the gate called NOT gate. So what is the symbol here? We have just observed, that is keeping one circle in front of this symbol, we got it as NOT gate. So this is the symbol for NOT gate and the truth table for NOT gate. Very simple here. Only one input and one output. Whatever the input we give, the output is reverse. That is, if you give 0, it is showing 1. If you are giving 1, it is showing 0. That is the NOT gate. NOT gate performs inversion operation. Any doubt in this one? Means very simple. That is the small inversion, that is low value is given, it is converting as high, high value is given, it's converting low. That's all, nothing to get worried about this. Let us go further. Okay, after observing the OR gate, AND gate and NOT gate, let us observe the next one, NOR gate. NOR gate means here NOR, NOR. What we observe something like OR and N, there's nothing but we can tell simple way is the combination of OR gate and NOT gate is called as NOR gate. What I told, the combination of OR gate as well as the combination of NOT gate is called as NOR gate. Observe, let us take the inputs as A, B. What we observed, A, B are inputs and this is OR gate. What will be the output if A, B is the input and OR gate is there? We found A plus B. Already we came across the OR gate. Now A plus B is there. After that what we are finding is NOT. Now the two inputs are A, B. First for OR, output of OR is A plus B. Now the A plus B became the input for what gate? NOT gate. Now as this is input for NOT gate, the output will be what? Output will be A plus B complement. A plus B complement is the output. So for NOR gate means inputs are A and B, outputs are A plus B bar or A plus B whole complement. Like that we can call. Instead of writing separately OR gate, NOT gate and getting like that, what can I do means I can take one symbol. That is, if you observe the combination of OR and NOR, what OR and NOT, what we can write here? Just put one circle in front of this OR gate and if you draw like that, now it is called as NOR gate. This is the direct symbol for NOT gate. Now what are the inputs? A, B are the inputs and what is the output? A plus B bar is the output. Simply now you can take this as a symbol for what gate? NOR gate. A, B are inputs. Output is A plus B bar or A plus B complement. Is it clear? Now our next step to the symbol is the truth table as usual. Let us observe the truth table for this gate. Now let us first draw it. That is, what are the general inputs will be taking? A, B are the inputs. And what will be the output? A, B inputs we wrote. Output is A plus B bar. A plus B bar is the output. Let us have first inputs for A and B as usual 0, 0. Again 1, 0, 0, 1. Finally 1 and 1. So it is just completely opposite to the OR gate. Whatever we got OR gate there, if suppose 0 is the NOR gate, in NOR you have to make it as 1 output, and 1 is the output in the OR gate, you have to make it here as 0. Just we have to inverse the OR gate output. It is a very simple way of writing. Otherwise, you observe here first thing what we have 0, 0. So, if you put 0 plus 0, what will become? 0, 0 bar is 1. So, the first one, what we have to write here? 1 is the output. Next, 1, 0. 1 plus 0 means what we observe? 1, 0. 1 plus 0 means 1. 1 bar. What we get again? 1 bar means what we get? 0. Now, let us be clear. 0 and 1 also. 0 plus 1 is 1. 1 bar. What we get here is 0. Again, finally, what we have? 1 and 1. So, 1 and 1 means 1 plus 1. What we get? 1. 1 bar. What we can write? 0. So, what we observed here in NOR gate? 1, 0, 0, 0 are the outputs. Is just opposite to our OR gate, that is 0, 0, 0 and 1. Just we have inverted the OR gate output, and that is observed as NOR gate. So the two main important things is, one is this truth table, and one more thing is the symbol for the NOR gate. Let us continue for our next gate. That is, what is that? NAND. NAND. Very similar to our NOR gate. The operation what we did you remember? Just we can say is a combination of AND plus what we call NOT is equal to NAND. In previous observation what we got? We have observed OR plus NOT is NOR. Now AND plus NOT is NAND. Let us have the circuit diagram. The first one, let us take the symbol for AND gate. Symbol for AND gate, you are very clear with that one. And then we have the NOT gate symbol. Just the combination of these two will give us what? NAND gate. A and B are the inputs. A dot B will be the output for what gate? AND gate. Now A dot B is the input, and what we get here? A dot B bar. So first what we observe, this is AND gate. A, B are inputs, output is A dot B. Already you are very clear with this one. Then what happened? A dot B is given as input for what gate? NOT gate. Now NOT gate what will do? Just it will inverse. That is, inverse means A dot B complement or A dot B bar, we can call it as. That is, whatever the input we have taken A dot B, it became A dot B bar. This is the final one. So the inputs are A and B, output is A dot B bar. This type of operation is performed in what gate? NAND gate. Simply what we can draw here, the symbol as, just observe here the symbol what we have, one circle in front of AND gate, it becomes NAND. So what is the output? Just now we observed A dot B bar. This is a simple symbol for NAND gate. So the inputs are A, B, output is A dot B bar. As this is the observation what we are having, let us further observe the one more important point is the truth table. The truth table, the two things in any gate what we are discussing. One thing is symbol, other thing is truth table. Let us have here A and B are the inputs. Output what we can draw? A dot B bar. So what are the input values we can take? Here 0 we can take 0, and one more thing is 1 0, and one more thing 0 and 1. Finally we can write 1 and 1. For 0 and 0 means what we have? 0 0 inputs. The output will be 0 into 0. 0 into 0 is 0, and 0 complement. 0 complement means what we get here? 1. Again 1 0. 1 into 0 is 0. 0 complement is 1. Again what we have? Input 0 and 1. 0 into 1. It is 0, and 0 complement is again what we can write? 1. And again observe the final one. 1 and 1. What we have? 1 into 1 is 1. 1 complement. 1 complement means what we can write here? 0. One more word we can say. It is just opposite to our AND gate outputs. In AND gate output, did you remember? 0, 0, 0 and 1 we have. Now what we are writing? 1, 1, 1, 0. Just opposite, because A dot B complement means opposite to AND gate. So what we observe? 1, 1, 1, 0. This is the truth table for what gate? AND gate. And what is the symbol? This is the symbol. So if you remember the symbol and truth table, then it is finished for the NAND gate work. Now, one important point to be noted is that is the two gates NAND and NOR are called as universal gates. NAND and NOR, these two gates are called universal gates. What is this universal gates means? Now the question arises, what is the universal gates means? Universal gates is nothing to get tense. It says that by using these two gates we can construct any other gate. By using the two gates, what are the gates? The NAND and NOR gate, we can construct any other gate. That is the reason these NAND and NOR gates are called as universal gates. Let us observe the NOT gate constructed by NAND. Here what you are calling this simple one is a NAND gate. But the two inputs are combined and made a single input. Now we must call it as NOT gate. Or we can draw this NOT gate by using NAND gate in this way also here. This is also symbol for NOT. We must not call these two gates as now NAND gates, because we have combined the two inputs as single one, and that is the reason we call it as NOT gate. Why means if you go back to the NAND gate truth table, you can observe 1 0 0 is there, what we got? 1 1 1 is there, what we got? 0. If the two inputs are same, output is opposite. If two inputs are same, 1 1, output is 0. Here 0 0 1 1 1 0. That means what we can understand here, this is the two inputs are combined or we are made as a single input, then that is called as NOT gate. Now please don't call, if the symbol is given like that as NAND, just you call it as NOT. Now these are NOT gate symbols. You must not call them as NAND gate. In the similar way, let us draw first the NOR gate symbol. You are calling this gate as what here? NOR gate. By putting some circle in front of this one, we call it as what? NOR. But if you combine the two inputs and made as a single input, or directly you have taken only single input, then we must not call these are also as NOR gates. If single input is there, now these are the symbols for what? Not gates. These are the symbols for not gates. So here A bar is given. It will make it as A. A is given. It will make it as A bar. So it is the symbols for not gate. We have to call the symbols are for not gate, not as NOR. Not as NOR, simply as NOT. As in previous case, these two symbols what we called? Not NAND. These are constructed by using NAND, no doubt. But these are called as NOT gate symbols. And these are also constructed by using NOR gates. But we call them as what gates now? NOT gates. Dear friends, I have to discuss further XOR gate, and XNOR gate, and I have to discuss the Boolean algebra, and next I have to discuss about De Morgan's laws. Like that, so much work is left. De Morgan laws I have to discuss. De Morgan laws, and I have to explain some graph work. So to find all these things in the same video, it is not possible. So let me take one more video and I'll continue in that. So in this particular video, what we observed is from the starting we will check it out. That is, the first we have got the gate is OR gate. This is the OR gate symbol and OR gate truth table. Next what we had, this is the AND gate symbol and AND gate truth table. Next this is the NOT gate symbol, NOT gate truth table. Next we had observed NOR gate symbol, NOR gate truth table. And we are observing now NAND gate symbol and NAND gate truth table. And also we concluded NAND and NOR gates are called universal gates. We observed these two things are construction of NOT gate by using NAND, and these two things are construction of NOT gate by using NOR gates. Like that we discussed these topics in this chapter. Our next topics are XOR, XNOR, Boolean algebra, De Morgan laws, and graphs. Okay, so this is the topics what we discussed. Now, before putting the end to this particular video and to continue our continuation video, I want to say two things. That the first thing is our team SAIVEDA Junior College, Mr. Seshkrishna Rao, Chemistry Lecturer, Srikanth, Zoology Lecturer, and myself, Gautam, Physics Faculty. We are working for you people. This all the videos which can make your work very easy and to have some enthusiasm to do the work in a simple way and to learn the things in a easy way, such that we don't feel something boring, and we have to develop a lot for NEET and JEE mains also. These videos are very much helpful. So my dear students, please pay attention. Thank you very much. Bye. All the best. Have a nice day.